In radicals, how we can model radicals? We have one example from real world situation. The number of eggs sold in a supermarket each day can be modeled by the equation y is equal to 4500 square root of 0.5x plus 2, where x is the number of the days since Monday. So x represents the number of the days since Monday. On what day will 9000 eggs be sold? So in the y-axis represents the eggs, how many eggs were sold. So in order for us to solve this problem, first of all, let's go in the Desmos and put in the Desmos this equation. When you put in the Desmos this equation, you're going to get this graph here. As we mentioned before in other lessons, we said the domain in a negative side does not make sense in the real world situation. But the domain has to be restricted from 0 to infinity. Infinity is impossible, but from 0 to whatever we can reach here to a defined number, or from 0 to infinity, let's say. And the range is from 0 to infinity up. So when you look at this function, I am disregarding this side. But here in the zeros, since said the day passed is Monday, I took the Monday. Let us set this day as a Monday. And when we are looking here in the graph, and when you drag the graph and you go to this point here, is going to tell you 4 and 9000. So in the y is 9000 and here is 4. So the day is the fourth day, can be sold 9000 eggs. So on a Monday, if you look, it's going to be 0 and 636, 3 point something, but because the x cannot be in decimal points, those are in units, 1, so I approximated this number with 6364. So on Monday already they were sold 6364, but from this day to the day 4th, which is Monday, is a 0. Let's say 1 is a Tuesday, Wednesday is number 2, Thursday is number 3, and number 4 is a Friday. So on a Friday there were sold 9000 eggs. But if we want this to solve analytically, let's say how we can solve it analytically. For example, we take this 9000, we want to see. We take this 9000 and we equate with the instead of the y, we write 9000, and the other, we just rewrite the equation in the form how it is 4500. Let me write it this way. And I have a square root of 0.5, 0.5x, x is plus 2, plus 2. So both sides I divide by this number here, 4500. 4500, I divided both sides. And what we are going to get, let me divide both sides by 4500, by 4500. And 4500, and here everything I divide by 4500. And what we get here, now this I can simplify 4000 with this 4500, and 9, this 20 we can take it away, and this 0 we can simplify, and 90 divided by 45 is equal with 2, and the other side is going to be equal with 0.5x, 0.5x plus 2, plus 2. What we are doing here now, we are going to square both sides this equation, and when we square both sides, here is going to be 2 square, but 2 square is equal with a 4, and then what we are going to happen here, if we have here this square root, and is going to be equal with a 0.5x, 0.5x, x plus 2, plus 2, and this plus 2 here, and everything here is in square. But the square here is going to simplify with the index 2. And then what do I have here? Here I have a 4. 4 is equal with a 0.5x, 0.5x, 0.5x plus 2. And I'm subtracting both sides by minus 2 here. Both sides by minus 2. And what we are going to get here, we are going to get minus 2 here and minus 2 here. So we're going to get here 0.0. Let me write with different color because we are moving here very 0.5x is going equal with 2. Equal with a 2. And divide both sides by 0.5x. Here by 0.5x. By 0.5. And I'm going here by 0.5. 0.5. So x is equal with, x is equal with 4. We already 4. So x is equal with 4 and y is equal with 9. So on a Friday, let me write here a Friday. Friday is going to be, the day is the 4 and it's going to be 9,000. 9,000 in the 4th day is going to be the, on what day? Here is a Friday. Just let me write here a Friday is a better. So on the Friday. On the Friday. So on the Friday, because I have a little bit difficulties to write with this, I am not very familiar. So on the Friday is going to solve the 9,000x.